Soon as series of system design, let's discuss the system design of IRCTC. So the basic question is why IRCTC, right? So it is a system which is dealing with a very high level of concurrency and also generating a lot of throughput as we need to handle the traffic during the Tatkal's time here since multiple users encounter that application at the same time. So let's analyze the different design level concepts which we see here. So one of the concept that is generally used is sharding. So are we requiring the sharding here? The question is. So if we see that why we require the sharding is we need to, when we want to divide the system into the smaller parts, it could be done by the various processes like a key based sharding could be there, a range based sharding could be there. So let's just analyze that are we requiring to divide the system into the smaller parts. So if we see the IRCTC application, so it generally deals with a billion of entries, which would be the entire population of the country. And since it uses the data for the 3 months ahead, right, as we can perform the booking for the another 90 days for it, so it would be generally using around 90 into 10 million, right, around 900 million seat bookings would be performed by the IRCTC in one time, right? So if we analyze the data for a single table during this booking, it would be around user ID, we would be storing train ID, date, seat, and source destination, other points, data parameters could be there. So around 50 bytes of data could be there for a single entry. So if we just calculate the storage for this, so it would be around 200 GB data for us. So here as we see that base there is no need of sharding as the data is very low here. Another point to this level concept that we generally inquire that is the system a read heavy system or a write heavy system. So discussing this question is really important as the entire architecture or the database choice depends on this answer. So let's analyze that what are the different systems here. So as we can see that a train list and schedules would be required to maintain. So it would be for us a static microservice, right? As the train list and schedules could be static and could be a read heavy system highly. Okay, so this we can consider the system as a heavy caching as a separate microservice built on caching and replicas. Another system we can analyze is the seat availability system. So the seat availability system is a highly, it can't be a consistent system all the time as the seats are just changing for us every time. So it would be a eventually consistent system for us, right? Another system which we can discuss would be the bookings table, right, which we would be doing. So it must be a highly consistent system because if it is not a highly consistent system, then multiple same bookings might be possible for us. So what we analyze is system 2 and system 3 that we had discussed are highly dependent on each other, where whenever there would be the right operations on booking table, the availability system would have to update itself to become the eventually consistent, right? So the system 2 can act as a caching layer, which is a read heavy, and system 3 would. So just let's analyze the different problems which we can encounter while designing this IRCTC. One problem could be the consistency here, right? As multiple users would be booking the seats at the same time. So basically we can break this process into the three simple steps, right? That once we will be checking the availability of the seat, if the seat is available or not, then we will be booking that seat and we will be returning the status of the booking seat if it was successful or if it was a failure. So basically what we analyze is that the transition from the step 1 and step 2, that there are chances that there are no seats left. So how to ensure that these three steps are atomic in nature, right? So either all of them would be passing or none of them pass. So here we can leverage the atomicity property of the relational DBs here. It's just really hard to make the operation atomic at the application server side, because here could be multiple servers behind the load balancer, and ensuring a global track of distributed atomicity across them is a very complex and error prone. So the database already guarantees the atomicity and consistency, right? So we are the transaction and the row level locking mechanisms. So atomicity must be enforced at the database layer. So by addressing using a relational DB, we can address the consistency issues here, and I will be providing you with a query that we can use while in the relational DB system here. The problem that we can see here is that how we will be handling the birth preferences here. So here we can use the order by to sort the records according to the birth preference, and the where clause to filter the records for handling the birth preferences here. While designing this problem, while designing this application, another problem could be that how we will be increasing the throughput. Since all the writes here go to the master DB, right, in the master slave architecture. So if there is only one master, it will become a bottleneck for us. So how we will be increasing the throughput then? So here we can use the sharding concept here, since we are not using it for the storage purpose, but because it helps us to have a different independent masters to increase the throughput. So the best solution could be to shard based on the train ID here. Since a single shard can contain multiple trains, but a single train is on only one of the shard. So So the train ID can be a good sharding key which will help us to horizontally scale by adding more and more shards to distribute the load between more and more storage machine. You can really stay consistent because for a given train you can only go to a single master where you can analyze and utilize the atomicity of the RDMMS update. So let me leave you with one of the design question, that how you will be designing the segmentation of the journey, since it is a bit different from the another types of booking like a make my trip where we just allocate that seat only once during a journey. But here on the IRCTC we can allocate that seat in multiple times during the same journey, as one person wants to hold from city A to city B, another person from city B to city C, right? So how you will be designing that problem? So yeah, stay tuned for more such educational content. Thank you everyone.